As we are working with definite integrals, we'll need to know some properties to help us. So at the end of this lesson, you'll be able to use the properties of integrals to evaluate definite integrals. All right, you'll notice the properties of definite integrals. The first one is just saying if as long as x is defined at x equals a, then the integral from a to a of a function is equal to 0. That basically is true because if you're going from, you're really not moving, you're not covering any area at all, so of course the area under that curve would be 0. Okay, if f is integrable, you can take the integral. Then if I have the derivative from the integral from b to a, it's equal to opposite the integral from a to b. So if you switch the endpoints, you switch them around, then you actually have to take the opposite of the integral. Okay, the third property is if we're taking the integral as long as it looks like we're integrable on 3 closed intervals, the integral from a to b would be equal to the integral from a to c plus the integral from c to b. So it's talking about something like this. If I'm going from a, we've got a, b, c here, and let's say we've just got this curve right here. It's just saying that if I go from a to c and then c to b, and I add those two together, it would obviously give me the area under the curve from a to b. And then the last one, if f of x is continuous, then it is integrable. So this one, we don't worry about sharp turns or anything like that. As long as the function is continuous, you can take the integral. So let's go ahead and use these properties. Right, the first one, it tells us that the integral from 0 to 3 of a certain function f is equal to 4, and the integral from 3 to 6 is equal to -1. And then in part A, it asks us to find the integral from 3 to 3. Well, since we're going from the same x value to the same x value without even caring what the function is, it automatically will equal 0. Okay, if I'm going from 6 to 3, I notice that I have an integral that goes 3 to 6. So I know this integral from 6 to 3 will be the opposite of whatever the answer is from 3 to 6. And we know the answer from 3 to 6 is -1, so it's going to be the opposite of -1, which will equal 1. And then the final example, if I would like to find the integral from 0 to 6, what I'm going to do, I notice that I know from 0 to 3 and 3 to 6, so this will actually equal the integral from 0 to 3 plus the integral from 3 to 6. And I notice that the integral from 0 to 3, we know that that is 4. The integral from 3 to 6 is -1, so 4 plus -1 is 3. So now hopefully you can use the properties of definite integrals to evaluate integrals.